All right, so let's go over the chapter 20 quiz. So hopefully it'll help you with the retake, and there's a similar problem on the final. So if you can do this one, you can do probably the one in the final. Well, hopefully this is a tricky problem. There's a lot to it. It takes a long time, but you got to get good at doing these things and doing them quickly because right in the final you only have 2 hours 50 minutes for this problem and 6 others. Yeah. Okay, so you got to do this. Now I'm going to take my time in going through explaining it, but on my own I could do it a lot quicker. Yeah, it's hard stuff. Okay, so first, our sinusoidal model always looks like this, right? A is the amplitude, B is the period, C is the phase, and that's the hard one to find, D is the average. Now, just by reading the question, I say the amplitude is 15. I didn't have to say that. You can look at the numbers because it goes from 385 to 415. But whatever, it's easy anyway. So that's 15. The average is what you set your oven at. It goes up and down over the average, right? So that's 400. That would be D. This is the average. B, again, is pretty easy to find out because I said that you put it in at 2 minutes, it's at 385. So a sine wave looks like this. So, right, so the bottom is at 385. This is a really bad sine wave. That's a horrible sine wave. Okay, so there we go. Bottom 385. The top is at 415. This is at, what did I say, 2 minutes and 4.5 minutes. So this is at 2 minutes, and it's 415 at 4.5 minutes. That's 2.5 minutes. So another 2.5 minutes, it's back to here, right? From the bottom to the top, back to the bottom. And that is a period. A period is from bottom to bottom, top to top, from where it goes up to where it goes up, like the same point in a wave, the same point in a wave. So 2.5 minutes here, plus another 2.5 minutes is 5 minutes. Right? That's from the bottom to the top is half the period. So right away we know the period is 5 minutes, and you just have to pick it up from that. So we know everything except for C, which is the hard one to figure out. So let's write that down now. So far, I'll use my black pen. We have the temperature is 15 sine of 2 pi over 5 T minus C plus D is, the average is 400. It goes up and down 15 from 400 because sine is alternately positive, negative, right? Okay, so we got to figure out C. Now there are 2 ways to figure out C. We can be clever or we can just do brute force. It's good to do both. Actually, let's do brute force first, and then we can be clever to check our answers. Does that make sense? Because sometimes you can't be clever. Sometimes you just have to use brute force. But the numbers I gave are pretty easy, so you could be clever. But let's use brute force. Okay, so we know we have 2 points. At 2 minutes, it's 385, and at 4.5 minutes, it's 415. So we know this one. We know the temperature when T is 2. So then the only thing we don't know is C, and we can solve for it. We can find out what C is. Okay, or we can plug in 415 and use 5 minutes. So we can plug in 5 and use 415. Either one works. We can just choose, so I'll use the first one. Okay, so we're going to solve for C. So when the temperature is 385 degrees, we know that the time was 2. So 2 pi over 5, 2 minus C plus 400. So what's C? Now we solve for C, we got to get C out of here. C equals something, right? Oh my gosh, that's going to be a lot of work. All right, so let's see. Take away 400 from here. That's negative 15. Divide it by 15. Amazing, right? It's negative 1. Everybody get that? 385 minus 400 is 15. Put the 15 over here. So I get 15 over 50, that's negative 15 because the 400 is bigger. 385 minus 400 is negative 15 divided by 15, that's negative 1, and that's equal to the sine of 2 pi over 5 times 2 minus C plus 400. Now, this is lucky we got negative 1. You don't always get something like that, but then you just use your calculator. But I don't need to use my calculator here because there's only one place where sine is negative 1. Remember, sine is the y value. The y value is up and down, and -1 is only one place. It's right there. And that, we can use two answers. We can say it's -pi/2 to get right there, or we could go this way, and that way it's 3pi/2. Okay? Either one works. Either one works. I'm going to go with the 3pi/2 because I like positive numbers. So, take the inverse sine of both sides, and what I'm saying is here, the inverse sine of -1, right? Take the inverse sine of both sides. Oh, I don't have the 400 here anymore. We got rid of that. Yes, sorry. This 400 is already taken care of. Inverse sine of -1 is 3pi/2. Right, that's what I'm saying here. 3pi/2 or -pi/2. So this over here is 3pi/2. That's a really bad 3. 3pi/2 equals inverse sine of sine gets rid of it, so we just have what's in the parentheses. 2pi/5 times 2 minus c. All right. Look at that. The pi's cancel. That's nice. 3/2 equals 2/5. So let's see. We want this. So let's multiply both sides by 5/2. Okay, by 5/2. That cancels out the 2 and the 5. I'm going to put this on the left because we want the c. So 2 minus c equals, let's see over here, we have 15 divided by 4. 15 divided by 4. Okay. C. 2 minus c multiplied by 5/2. 2pi/5. Am I doing everything right? Equals 3pi/2. Yep, this is all right. Okay, so put the 2 over here. So -c equals 15/4 minus 2. Let's see, 2 is 8/4, right? So, I know I did something wrong. Okay. What we gotta do, whenever we do this inverse sine thing, we have to, I'm gonna stop here. Okay, this is where, now you don't really, well, okay, yes we do. Take the inverse sine of both sides. Inverse sine of -1 is, like I said, and I'm going to actually switch this around. I'm going to put this first over here. That's what messed me up. 2pi/5 times 2 minus c equals inverse sine of -1, which we said is 3pi/2. But that's when, remember, right away we add the 2pi in. We add the 2pi in there. Okay. And that'll make a difference. So, okay, so now let's do it. So the pi's cancel everywhere. We have a pi everywhere. That cancels. Multiply both sides by 5/2. 5/2. So let's see, then we get, that takes that, so we have 2 minus c over here. 5/2 is 15/4 plus 5/2 15/4 plus 5/2 times this is just plus 5n, which this should always end up being the period times n. That's a good way to check to make sure you did it right. It's always, plus you can always add the period to c. That's the idea, you can always add the period to c. Well, now we subtract 2 from both sides. 2 is 8/4, so negative c is 15/4 minus 8/4 plus 5n. Or c, okay, which is what? 15/4 minus 8/4 is 7/4. So 7/4 plus 5n. Or c is the negative of this. Right, that's negative c. So finally, I'll write it right here. C is equal to negative, so now negative 7/4, I like decimals. 7/4 is actually pretty good. But that's also 1.75, right? 1 3/4. So c is negative 1.75 plus or minus 5n. Minus 5n. Now, c is negative. I like a positive c because it's minus that. It's always nice to have minus the first positive number. So you could put negative 1.75 and put plus 1.75. That is a correct answer. Nothing wrong with that. But it helps me visualize it because I'm not graphing over here on the negative side, right? I want to graph on the positive side. So I'm going to add 5 to it. Oh, by the way, when we do the negative, it's really minus 5n. Sorry. Yeah, I did that right. Never mind. Minus 5n, but n can be positive or negative. So plus, saying minus 5n is exactly the same thing as saying plus 5n, because n can be positive or negative. So I'm just going to leave it as plus because it just looks nicer, because it doesn't matter. Anyway, I want a positive one, so I'm going to make n equal 1 and add 5. So that would give me 5 minus 1.75, which is 3.25. That's the smallest positive number we have, because the one smaller is negative 1.75 and one bigger is 8.25. Okay, so we want the smallest positive number. So C is 3.25. So now we have C. Now, we could have also figured that out. Okay, C, by definition, C is, and this is really important, okay, the C is where the sine wave starts going up. Normally, C is right there for our normal sine wave that's not shifted. That's got the phase of 0. C is the phase. But if we shift our sine wave over, okay, so C is always where it's the middle of the sine wave starts going up, right? Which is normally that's at time 0, at 0 right there. But if we shift it over a little bit, we shift our sine wave over a little bit, then C is how far we shifted it. That's what C is. It tells us where the middle of the wave is and starts going up. It's always the middle of the wave. So it's where the middle of the wave is, where it hits this middle line. Now, I know that the minimum is at 2, so I can put a dot there at 2. The maximum is at 4.5, so I can put it at 4.5 minutes. So the minimum is halfway between there. That's why I said we can check our answer by symmetry. It's halfway in between 2 and 4.5. That's a 2.5 difference. Half of 2.5 is 1.25. So it's 2 plus 1.25, which is 3.25 minutes. So it's right in the middle at 3.25, halfway between 2 and 4.5, which is 3.25. So this is 3, so a little bit more than 3, so it's something like this, right? 3.25, so that's 4, so something like that. So I didn't have to do all this math, because in this case, since I gave you the minimum and the maximum, you know that C, you know that it's going up right in the middle between there. Okay, but that was a lot of fun though, wasn't it? So hey, not wasted time. Okay, so that's how you find C, and you sometimes, if depending on what you're given, you can figure it out without having to do that math. And might as well do both, except that it takes a lot of time. Okay, so a lot to do there. That wasn't really necessary because again, we could have figured it out real easily just by thinking about it. All right, so there's our formula there. Now we know what C is. So I'm going to leave this up while we do the rest of it, because we have a lot of work to do and I'm already taking forever in this video. Oh my God, it's already 13 minutes. Okay, so I'm going to erase this because I can, and I'm going to put C there. So it's T minus 3.25. T minus 3.25. In other words, our sine wave is shifted 3.25 to the right. Right? If you take away, this is like X. If you take away from it, you minus from the X, it's shifted to the right 3.25. So it's shifted to the right 3.25. Normally this part would be here, but now it's here at 3.25. Okay, now let's draw our sine wave. We can draw it now. So every 5 minutes, the period is 5 minutes, every 5 minutes is at a bottom. So at 2, and then at 7 it's there, so my 7 is somewhere right about here. So it's going to be there. I'm going to use the blue pen to draw my wave, so it's right there. At 12, it's about right there. And at 17, it's about right there. And I'm going to stop there. And then every 4.5 minutes, every 5 minutes add 4.5. That's a little bit awkward. It's at the top. So a little less than 10. So right about here, or basically halfway between those two dots. That's another way, which is a little less than 10. Right there, a little less than here. It's again halfway in between. So just to draw it, so right about there. And then it's halfway between that. It goes there. So now I'm going to try to draw it. So it's going to be something like this. So it's going to go something like this. Oh, that one was kind of weird there, huh? Oh, and then it doesn't go straight through there. It always starts curving up before that, right? So something like that. Okay. It's hard for me to draw way up there. It's a lot easier in a desk. Okay, there's my sine wave. So, well, we want to know when it's 410. Okay, so when is it 410? So I'm going to draw a line across when it's 410 degrees. So it's 410 here and here and here and here and here and here. So we got to figure out how long is it above 410 for each cycle. That's one of our problems. How long is it above 410 for each cycle? And then we can figure out how many cycles. And we might have some partial cycles. Okay, so we got to worry about that too. Like, for instance, does it get to 410 right here, right? Is it at 410 at 0? However, that doesn't matter because we put our muffins in the oven at 4.5 minutes. When we put them in at 5 minutes, right? We put our muffins in the oven at 5 minutes. Yeah. So we put our muffins in here at 5 minutes. And so it looks like we're going to have a little bit of this cycle, right? Because its peak is at 4.5, so here's 5. So we're going to have a little bit in this cycle, and then a whole bunch of whole cycles, and then probably a little bit at a last cycle. So it's going to be a little bit confusing. Okay, so we got to figure that out. A little bit here, a bunch of full cycles, and then probably it's going to go a little bit in the last cycle. So that's our trick. So we got to figure out when this wave is 410. So now, we already did it once, but now we do it again, and this is part C. I think I called this C. Solve for the times when the oven's at 410. So now we do the exact same thing we did. 410, except now we know C, we've got to figure out T. 410 is 15 sine 2 pi over 5 times T minus 3.25 plus 400. So we got to find out when those times are. We're going to get a 2 pi in, and there's going to be a symmetry in a principal solution. So let's see. Put the 400 over here like before. We get 10 divided by 15. So I have 10 over 15 is equal to sine, and I'm just going to do this. Kind of cheat, not write everything in parentheses. Take the inverse sine of both sides. That gets rid of the sine, and this is inverse sine of 2/3. And I'm going to write what's in the parentheses now. I'm going to switch the order here, right? Because I like writing this stuff on the left because we're going to be solving for t. So I'm going to put the parentheses over here. So I have 2 pi over 5 t minus 3.25 equals, because the inverse sine got rid of the sine, but we have the inverse sine of 2/3. So inverse sine of 2/3 plus, as soon as we take this, right, as soon as we take inverse sine, we get this in our calculator, plus 2 pi n. Plus 2 pi n. Can't forget that. Super important. Now, we get this in our calculator. And that's going to be, so I already did this, so I don't need to use my calculator right now. So the inverse sine of 2/3, I got that to be 0.7297. Make sure you're always using radians, okay? Always use radians in your calculator. 0.7297. That's the principal solution. Okay, so the principal is what your calculator spits out, 0.7297. So I get 2 pi over 5 times t minus 3.25 equals 0.7297 plus 2 pi n. Again, that's the principal, what your calculator spits out. Now you solve for t, and I'm going to save you some trouble here, and I'm just going to write the answer. So you got to multiply by 5 over 2 pi, add 3.25 to both sides, do all that stuff. And you can try that and make sure I did it right. I get 3.83 plus 5n. So I get this 3.83 plus 5n. You should always get the period times n, which I did. 5 is a period, so we know that works. You can always add the period to the phase, because the phase could be here, or it could be here, or it could be here, right, where it starts going up. You can always add 5. All right, now the symmetry solution, the next one, is instead of 0.7297, it's always pi minus that. We just plug in pi minus that. So we have 2 pi over 5 times t minus 3.25 equals pi minus 0.7297 plus 2 pi n. Okay, and then like we do before, we multiply both sides by 5 over 2 pi. After we subtract this and solve for t, add 3.25 to both sides. And when I did that, I got t is 5.17. And check and make sure I got this right so that you could get it, plus 5n. Okay, so this is the 3.83. So right there, that's the first one. That's at 3.83, which it looks like it is, right? Here's 3.25, 3.83. Yeah, that makes sense. So this time there is 3.83. This time here is the other one, is 5.17, which it looks like it, right? A little after 5, so sure enough, 5.17. That's good. All right. So that's one cycle. So that's, anyway, yeah, so that's what I called part C, solving for that. Now let's figure out how to use this. So part D I called it, but you don't have to do it in part D. I was just trying to pick it up, so whatever. Okay, so now what do we do with this? So in one cycle, we have 5.17, we subtract those two, right? Minus 3.83, and I got that that's 1.34. So every cycle gives us 1.34 minutes. All right. Oh, so the first cycle, we put it in at 4.5, and it lasted for until 5.17 minutes. So we already got some time in the first cycle. So it's 5.17 minus 4.5, right? We put this muffins and muffin at 4.5, and it's going to be 4:15 all the way to 5.17. We got this little bit of time right there. And so that is 0.67 minutes. So the very first cycle, we got 0.67 minutes. Everyone after that is 1.34 minutes. We got to get to 8. So let's see. I think we got to do at least 5 more full cycles. And you just check that, right? Or we can divide it by 8. 8 divided by 1.34. This is the way to do. So we take 8 minutes. There's 1.34 minutes per cycle. So 8 divided by 1.34, I got 5.98 cycles. We need 5.98 cycles. So we need 5 full cycles and a little bit more. Well, I already got 0.67 minutes here. So we got a little bit of a cycle. So probably we're going to need 5 full cycles and a little bit more of the last one. So let's try that. So 5 full cycles is 1.34 minutes. So what's 5 times 1.34? I got that's 6.7. So that's 6.7 minutes. Plus we already had 0.67 minutes from the first one. So we get 5 full cycles, 0.67 minutes. So what's that? So 6.7 for our 5 cycles plus 0.67 minutes that we already got from the first one. And that is 7.37 minutes. So 7.37 minutes. Let's see, that is after 5 cycles. So we get this first cycle and then 1, 2, 3, 4, 5 more. Right? This first one we got only a little tiny bit, 0.67. We need 5 more. That gets us to 7.37. And then to get to 8 minutes, we got to do that little bit extra of that final cycle. Okay, so that means we need 8 minus 7.37, which means 0.63 minutes from the very last cycle. So we need to go into that last cycle. So we got this one, 1, 2, 3, 4, 5, and then 0.63 minutes after that last one starts. All right, we are almost done. So let's figure that out. I'm going to keep all this stuff up, but we can do that here. So I think this is like part E now. And I'm just going to do, because it's really tricky to think about these things. So let's just make a table here to make sure we don't make a mistake. Okay, so let's see. Cycle number 1, let's call this cycle number 1. It started at 3.83. Cycle number 1 started at, so let's see, it starts 3.83. 3.83. The next cycle started at 5 minutes later. Every cycle starts 5 minutes later, which is easy math. So the second one starts at 8.83. Yeah, that's right. The third one starts at 13.83, and the fourth one started at 18.83. I'm going to run out of room. And the fifth one, 23.83, sixth one, 28.83, seventh one, 33.83. Okay, let's check now. This first one we only got, the first cycle we only got 0.67 minutes out of it. So we got 0.67. Here we got the full 1.34, 1.34, 1.34, 1.34, 1.34. Okay, our 0.67, 5 1.34s, and then this last one we had to get 0.63, 0.63 out of it. It started at 33.83 minutes. So we go 33.83 plus 0.63 minutes, and that will be when we can take them out of the oven. This cycle starts, we got to wait 0.63 more minutes, and then they'll be done. Then we'll get to, we add all these up, all those numbers add up to 8. So what is that? 33.83 plus 0.63 is 34.46. Yeah, I better check that math, because this is so exciting, because we're done. That's our answer, if I did it right. 33.83 plus 0.63 is 34.46, yes. So after 34.46 minutes on our stopwatch, we take them out of the oven. I don't know why there's so much a big space there. 34.46. 34.46 minutes. We take them out of the oven, and they've been above 410 degrees, for 8 minutes. Phew. It really, really helps me to draw this out. Trying to be clever, and you had, okay, 5 cycles, whatever, is really tricky. Again, make sure this adds up to 8.67, 5 of those, right? So we figured out over here, we need 5 1.34s. That gets us to 6.7 minutes. We already had the first 0.63. We need 0.63 more to add up to 8 minutes. The last cycle starts at 33.83 minutes, right? Way over here. I didn't even draw it because I don't want to make my drawing that big. I can just know this has to happen. But let's say it's this one here. Starts at 33.83 minutes. We leave it another little bit longer, 0.63 minutes longer, and we get to what we want. All right, that took me 28 minutes to explain. I could probably do it in half that time if I didn't have to be up on the board explaining all these things and everything. Oh, can you even see the bottom part? Yeah, more or less can. Yeah. So hopefully once you get the hang of these things, you can do them a lot faster. You know, heck, try doing this again on your own. I already put up a practice quiz. So sorry, a retake. It's similar. I just changed the numbers around a little bit. So yeah. Okay. Hope that made sense. These things are tricky. They're hard. That's why they're chapter 20. There's the last problems. There will be one like this in the final. Similar, but different. You know, you got to think really clearly, draw a good picture, really think about what's going on, really think about the phase, you know, finding C. Does your C make sense? Does it make sense where the picture is? Do all these numbers make sense that you end up finding? Always remember things like the middle part here is halfway between a peak, trough and a peak. So where C is where it always starts going up. That's like the beginning of the wave, because right, the sine waves are supposed to be here. They start the middle here going up, but we shifted it over. So now it's there. We shifted it by 3.25. Yes. And of course, if you get this wrong, then everything's wrong. So be really careful you get the average right. What's the middle? How much the amplitude? How much above and below does it get? Yeah. Okay, good. Thanks for listening. Hope it made sense. Yeah. Good luck. Bye, everybody.